Okay, coming down to the last couple examples. Last couple examples in the class, actually. Well, I've had a good time. I hope you have too. I hope you think I'm pretty cool because, well, I certainly think that I'm cool. Is it? It's good? Okay. My method on the microphone is banging. Wu-Tang Clan will leave your headpiece hanging. Okay, pause and copy. Now, do something new here. Find the distance between two skew lines. So skew lines, L1 and L2, are not meeting each other anywhere. And we're going to draw their direction vectors at the origin and try to think about this in a different way. So what I want you to do is a little visualization. I'll try to help you out here. I'm going to take this stuff here and move it like that. Now you see what we have here is a triangle. A triangle like there. I want you to consider the plane that contains the triangle. The plane that contains that triangle. We'll call it P1. I'll write the vector parametric equation for that, or parametric vector rather. Well, it contains this vector here, right? So I'm going to put 2, 1, 1. And then it has two direction vectors. What are the direction vectors? Well, they are U and V, right? So I'll write those down. S times U, 0, 1, negative 1, plus T times 1, 1, 1. Now I would do the same thing at L2. So I would take this triangle here, and just imagine it sitting down here. See, just shifting. That's pretty bad, but U and V there. So same triangle as above. Now imagine the plane that contains that triangle. Call it P2. And it contains this vector here. And the direction vectors are U and V again. Now, let's redraw the vectors U and V here with the origin. Okay, now we have these two planes here. What do we notice? They notice that they have the same direction vectors, right? So they are parallel. P1 and P2 are parallel. So two things that take a bit of thinking about. One, P1 and P2 are parallel. And the harder thing to think about maybe is that the desired distance is the distance between P1 and P2. Okay, that takes some visualization. You got these two planes that are parallel. And how did it go? L1 was going like, okay, L1 was going like this. L2 was going like this. Now we're trying to find the shortest distance between L1 and L2. And what I'm trying to say to you is that distance is in fact the shortest distance between P1 and P2. So we can simplify this further. The desired distance is the distance, between. Well, what I can do is just take a point, any point on one of the planes, say P1, and find the distance between this point here and the plane down here. So this reduces to finding the distance between a point and a plane. So we can choose this point. We'll choose that to be 2, 1, 1. And then we'll find the distance between 2, 1, 1 and P2. Okay, so this is something we've done before in 5.5, finding the distance between a point and a plane. I'll get you started, but I would like you to do this. So to get you started, I'll find a normal vector for P2 for this plane here. Okay, and what I do is I take the two direction vectors for P2 and I do a cross product and I get this guy. Okay, so you can, as an exercise, finish this. You can use the method that I taught in 5.5, or you can look in your textbook. There's actually a formula. There is a formula that you can memorize if you want to for the distance between a point and a plane. So I'll leave that up to you. So pause and try that. And the answer here should be 1 over root 6, or root 6 over 6 if you prefer. Okay, I'd like you to try one of these from top to bottom. So same question, but the first line is 1, 1, 0 plus t 2, 3, 1. Line 2 is 3, 1, 3 plus s 0 to negative 1. So skew lines, I want you to find the shortest distance between them, following what we just did. So pause and try that. And hopefully at the end, you got 2 over root 45, which, being good mathematicians, we can reduce. There's a 9 in there, so 6 root 5 over 45. Divide top and bottom by 3. This is really tedious, but I just have to, you know. Okay. Make sure I didn't screw that up. 9 times 5 is 45. That comes out, divide top bound by 3, 2, and all right, there you go. Hopefully you got one of these things. I don't need you to reduce it, but it sure is pretty.